Alright, ladies and gentlemen, here we go. We're going to start with 2.3. And let me go ahead and open this up. In 2.3, we're going to do a lot of review, some of which may seem very easy, but don't, assume. So we're looking at section 2.3, and this is linear functions and slope. All right. And so we begin with the slope of the definition of a slope. So you've seen this before, where we look at a slope of a line if given x1 and y1, and say I give you x2 and y2. We are basically looking at the slope of the line as the change in y, which is y2 minus y1, over x2 minus x1. We always note that this is the vertical change, and obviously our x values are horizontal shifts or horizontal change. If we were to look at the diagram, we have discussed this before. We also note that we refer to the slope of a line, of a straight line, as rise over run. And that's just like a little description of what's happening. And doing so, we're looking at a coordinate plane where I have a y-axis and x-axis as normal. And let's assume I have a line going this way. And let's plot 2 points. I'm just going to take these two and pretend these are my x1, y1, and so on. And so what they do in the book is that they basically draw a horizontal line this way, crossing that, a vertical line crossing this point here, creating this little triangle, as you can see. And they refer to this as the rise, and obviously this as the run. This would be the equivalent of our points, so let's call this x2, y2. Same 2 points we were discussing earlier, and this would be our x1, y1. All right, where this is x1 here on the x-axis, and this would line up with x2 on the x-axis. Obviously our y values would line up equivalently, so this would be our y2 value, and this would be our y1 value. All right, nothing you haven't seen before, right? And we also assume that in this case, if we're looking at the definition of a slope, and we're looking at example 1, they want us to find the slope of the line passing through and then they start with example A. They give you 2 points. They give you -3, -1, and -2, 4. And that is the first question they give you. So the first thing you want to do in this case is begin with your formula. I always say label, so x1, y1, x2, y2. So using our formula, we would say y2 minus y1 over x2 minus x1. And this leads us to 4 minus -1 over -2 minus -3, which ends up giving us 4 plus 1, which is 5, over 1. In essence, our slope would be 5 for this particular question. Remember, the slope is always m in our formula. In question B, they give us the following. They give us the 2 points. They say -3, 4 is our first point. And the second point given to us is 2, -2. Again, I would label x1, y1, x2, y2, and this becomes y2 minus y1 over x2 minus x1, and this becomes -2 minus 4 over 2 minus -3, which then becomes -6 over 5, and that is our slope. So I'd like to give you a try question. Let's go ahead and try this, and we'll do these together in class. Make sure you have the material. So we have 2 points, -3, 4, and we're also given the point -4, -2. So we'll call this example C. Example D, we're given 4, -2, and we're also given -1, 5. Okay, I'll give you a few minutes to try this in class. I am also going to pause the video to give you the response right after. So the answer are, for part C, your slope is 6, and for part D, your slope should be -7/5. All right. We also have the name conventions for the direction of the slope. And so if I'm looking at a coordinate plane and I'm looking at the x-axis, y-axis behavior, if I have a line that is increasing left to right, remember we always read left to right, it's going up, we refer to this as a positive slope. If the reverse is happening and I have a line that's going down left to right, so left to right is going down, we refer to this as a negative slope. We also have the notation that we use. We also use m is less than 0 for negative. And for positive, we say m is greater than 0. That's how we denote positive and negative in algebra. Now, there are 2 other ones. We have what we call the horizontal slope, and in which case we would refer to the slope itself equal to 0. And in that case, they call it the zero slope. So these are all names that they can give this particular diagram. And so again, if I have an xy axis sitting as such, this line would simply be going across this way. And so notice that my y value will be identical for any x on this particular x-axis. We also have the vertical line. We refer to the vertical line as an undefined slope. This happens when the x1 and x2 cancel out to equal 0. So again, if I'm looking at an xy axis, this is unfortunately like we would think of a plane descending. You're looking at a vertical drop this way and this way. So this happens when x2 is equal to x1, and therefore when you use this little formula, the difference of x2 minus x1 is equal to 0. So keep that in mind. For the horizontal, the y2 minus y1 equals 0, but that's okay because it's in the numerator. We're okay with that. All right, we're going to talk next about the point slope form. And point slope form is related to the slope formula. So if a slope formula is simply y2 minus y1 over x2 minus x1, to solve for this, I simply end up by multiplying on both sides by x2 minus x1. So if I take this and I multiply it by x2 minus x1, multiplying this side by x2 minus x1, notice that I end up with y2, I'm just flipping around, minus y1 is equal to the slope times x2 minus x1. And that is your point slope formula. All I did was move it around a little bit. That's it. So in example 2, we're going to write an equation for a line in point slope form. So what they're saying here is they want us to write an equation in point slope form for the line with slope 4. Now sometimes they're going to say the word slope and sometimes they're going to say m4 that passes through the point -1, 3. And then solve for y. So basically in this case, we're going to start with what's given to us. So we do have an x1, y1. So I want you to label immediately x1, y1. And we're going to start with the formula. Y minus y1 is equal to that slope times x minus x1. What are we given? We know that this is y minus 3. This is equal to 4 times x minus 1. And so we apply what we know. We know that y minus 3 is equal to 4 parentheses x plus 1. We distribute R4. So now you have y minus 3 is equal to 4x plus 4. Add that 3 to both sides. And now you have y is equal to 4x plus 7. And that is the equation in slope intercept form for this, given that information. So if I said to you, I'm going to give you the same question. So I'm going to give you the try question here. So I'm now going to scratch this out. I'm going to call it the try question. And I'm going to ask you to change the point from -1, 3. We're going to change this point now to 2, -5. And our slope, we're going to call that slope 6. So I'm going to change this to 6. Go ahead and try that question. I am going to leave this here for you so you can at least follow that part and then go from there. So I'll go ahead and pause the video and you're going to try to work this out and let's see what you come up with. Your final solution for this, so I'm going to write down solution to remind myself that this is where I paused. Well, you should have y equals 6x minus 17 in slope intercept form. Remember, this is slope intercept form. Okay, and in point slope form, you should have y plus 5 is equal to 6 parentheses x minus 2 as you solve for y. Okay, moving on to example 3. In example 3, we're going to write this equation. So write an equation for a line in point slope form. All right, so the question that they're asking you is to simply write an equation in point slope form for the line passing through the points and then they're going to give you 4, -3 and the point -2, 6. Okay, so I'll give you a minute to think about this and then I'm going to walk you through. So the first thing I think I need to do is find the slope. And to do that, I need x1, y1, x2, y2, and apply the formula. So regardless of the order in which I'm going to do this, let's say hypothetically I go this way and I say 6 minus -3 over -2 minus 4. Notice my slope is -3 over 2 once I reduce. And I'm now going to select a point. So I'm going to select a point. So I'm going to put for you here to remind you, use point 4, -3. So again, this will become y minus -3 is equal to -3 over 2 times x minus 4. All right, a little bit of math here. This becomes y plus 3 is equal to -3 over 2 parentheses x minus 4, which means I need to distribute this. This is now going to become y plus 3 is equal to -3 over 2x plus 6. Remember, 3 times 4 is 12. Negative times negative is a positive. So 12 divided by 2 is 6. And that is, at the moment, you're partially done. Subtract your 3. And now here's your final answer, where y equals -3 over 2x and then plus 3. All right. And so any questions on this we can discuss. And if not, I'm going to go back to the original question and I'm going to simply erase these points. Let's change these numbers up a little bit. Let me give you these in red so you understand this is the second question. So -2, -1, -1, -6. Those are your 2 new points. And so you're going to follow the same steps we took here, which is to find the slope. All right, so find it using the method we've discussed. Select the point. For the sake of the example, it's up to you which point you want to use. And then we're going to apply our formula. So I'm going to stop here, give you a few minutes to do this work. And I then want to discuss this with you. Okay, so your solution should be, in this case, y plus 1 equals -5 parentheses x plus 2, or y plus 6 equals -5 parentheses x plus 1, which in both cases simplifies to y equals negative 5x minus 11. Okay. We've talked about slope-intercept prior in class. Slope-intercept form. And so slope-intercept form is where we have y equals mx plus b. And so they want us to learn how to graph an equation using only the slope and the y-intercept. Now, remember the y-intercept is where x is always 0. And so in this case, they want us to graph, and this is example 4. They want us to graph f of x is equal to negative 3 over 2x plus 2. Okay, so always remember that when you do these questions, if I'm using the intercept, all you have to do is create an xy grid. You need 2 points to graph a line. If I'm using the intercept, I know x is 0. When x is 0, y is 2. I know that because it's right here. X has to be 0 because all of this has to kind of like go away. So I know that. I know the slope is negative 3 over 2, which means this is a change in y. This is the change in x. Okay, so that means that I'm going to lose 3, gain 2. Notice that this is the x, obviously the y. So you have y and x. I'm losing 3. I'm gaining 2. So my next point is actually 2, negative 1. X is 2, y is negative 1. So if you were doing the counting method, we know when x is 0, y is 2. So I'm going to go down 3 units, 1, 2, 3, and from here, I'm going to count over 1, 2, and now I'm here at this point, which is 2, negative 1. So when I connect this line looks something like that. Okay? I would like for you to pause this video. Let's try this one together. So this is your try question here. I'm going to give you graph this question. It says a graph f of x is equal to 3 over 5x plus 1. All right, I'll give you a few minutes to do that, and I'll show you that on Desmos. So just hang tight. Pause the video if you're watching this. So I'm going to go to Desmos and I'm going to model this for you using Desmos because Desmos does pretty work. And again, I ask you to use this calculator or this graphing device just to help you visualize, but you need to understand where this comes from. This is what your line should look like. Notice the 2 values. You only need 2 points to graph a line, right? So you can see that you have, looks like a weird kind of decimal there. You have, but there are at least 2 points you can find. So let's play with this one for a minute. Okay, so here's x, here's y. When x is 0, y is 1. Again, this is the tattletale that tells us this, right? According to the values, we're going to go up 3 for the y and up 5. So the next point that should be significant should be the 0.54. With those 2 points, I should be able to graph my diagram. So here we go. So if I'm at 0, 1, 0, 1, this is the point 0, 1, that's our y-intercept. Like I said, I'm going to go, I could go up 3, so 1, 2, 3. And I'm going to come over 5 units this way. So 1, 2, 3, 4, 5. Hypothetically, this is what our diagram should look like. Let's look at Desmos again. Is 5, 4? Yes, it is. Look at the 5, 4 right here. 5, 4 is this point right here. I'm going to try and click on it as best I can. There you go. And you can see it clearly in the video that is 5, 4, and in class I'm actually going to show you as well. All right, so that is what they want you to do there. Now, questions 5 and 6 are actually very easy, but a lot of students get confused. And I don't want to do them side by side, but I think I should. So let's do examples 5 and example 6 side by side. And the reason why one is a vertical, one is a horizontal line. So this is a horizontal line, this is a vertical line. So they want you to graph y equals -4 in this one. In example 6, they want you to graph x is equal to 2. Okay, it's simple. Here's your xy axis. If it's a horizontal line, x is -4. So I'm here, and I'm going to graph all the values encompassing that right here. So this is the line where y equals -4, and it is a horizontal line. If I look at a vertical line, notice that in this line, x is my point of reference, so I'm looking at x is equal to 2. X is equal to 2 is over here, so 1, 2, and I'm drawing a vertical line going straight up and down. That's it. That's all you have to do for both of these. No vertical lines represents a linear function. No vertical line represents a linear function. Obviously, you're hitting more than one point, and it is the vertical line test. It will actually fail the vertical line test. Okay. As far as horizontal lines are concerned, basically these are the ones that the slope is equal to 0. In this case, the slope is undefined. All right. Let's talk about example 7. And this has to do with the general form of the equation of a line. So in this case, we're looking at ax plus by plus c is equal to 0. Okay, so here's an example in example 7. They're telling us to find the slope and y-intercept. And pay attention to this chapter. A lot of this chapter is actually on your PSAT. So in this case, find the slope and y-intercept of 3x plus 2y minus 4 equal to 0. So what I would do in this case, I would subtract the 3x and add the 4 and bring it to the right side as negative 3x plus 4. This would leave me with 2y is equal to negative 3x plus 4. I'm now going to divide by 2 on all 3 terms. Notice that the 2's are going to cancel, so you're left with y equals negative 3 over 2x plus 2. And so your slope is negative 3 over 2, and your y-intercept happens to be 2. Now, here we go again with Pearson. In Pearson, they're going to either ask you just to write down the 2 or to write down a coordinate pair 0, 2. Example 8. A very similar question. They're saying here using intercepts to graph a linear equation. Okay, and then they give us 4x minus 3y minus 6 equals 0. Whenever they say this, you're going to basically create an XY grid. And you're going to divide it into 4 pieces. In one case, x is going to be 0, and the other case, y is going to be 0. Now, for all intents and purposes, I'm going to give you one that's going to make a little more sense. So I'm going to actually change the 6 to a 12. And notice that I'm also going to tell you that 4x minus 3y is now going to actually equal to 12. So if I use this part first, I'm going to say 4 times 0 minus 3 times what is equal to 12. Well, the answer for this would have to be a negative 4, because that's a positive 12. So this would be 0, negative 4. If I'm using the bottom part, I'm going to say then 4 times what number minus 3 times 0 equals 12. So if you notice these zap out respectively, this would have to be a 3. So that means that when I graph this, I'm simply going to grab 1, 2, 3, 0, 1, 2, 3, 4, 0, negative 4 is down here, and this line would look something like this. That is the idea behind that one. So go ahead and try this one. Go ahead and graph, and I'm going to try and give you a nice easy one here. Using intercepts, which means just using 2 points, 3x minus 2y minus 6 equals to 0. I'm going to do number 9 with you. For number 9, I am going to use the textbook. So let me pull the textbook up. Okay, I'll use the first period. Go to your textbook, or go to section 2-3. Okay, we'll go. Table of contents, chapter 2. Section 3. What a cute little bear. All right, so we are going to move over. So all of the notes that I provided you here come straight from the textbook. There's no surprises. All right. All right, here's a question that I wanted to share with you. So this is a modeling global warming question. It's a little bit scary, huh? Look at the carbon dioxide concentration You're also looking at the right side. You have the temperatures of the global temperature comparison there. That's terrifying. So it says shown on a scatter plot. So the scatter plot is the diagram to the right. It says there is a line that passes through near 6 points, and so you can see it there. That we call it the line is best fit. They do give you 2 points. They give you 326 and 57.06, 385 and 57.99. Okay, so they basically giving you an x1, y1, x2, y2. They're asking you, using that information, so it says write the slope-intercept form of the equation using function notation. Okay, this could also help you with what we're discussing this coming week with respect to PSAT practice. So if we do the example, you notice that there is a change of 0.02. So the slope indicates that for each increase of 1 part per million in carbon dioxide concentration, the average global temperature is increasing by approximately 0.02 degrees Fahrenheit. It's terrifying. Then they're asking you to come up with the equation of the line, so just select any one of the 2 points. So they selected the point 57.06 and 326. So using that information, they plugged it in, they distributed the 0.02, and then they arrived at the equation, which is y equals 0.02x plus 50.54. That answers part A. In part B, they're asking us in this case if it doubles. If the carbon dioxide concentration doubles from its pre-industrial level of 280, which is now 560. All right, if it's doubled, 280 times 2 is 560, right? Okay. So then using this very formula, plug in 550 or 560, you have F of 560, and I'll show you here on this screen, F of 560, notice the change, and so that is now equal to 0.02 times 560 plus 50.54, which gives us a 61.74 degrees Fahrenheit, which compared to the 57.99 degrees Fahrenheit is a 3.75 degree change. Global warming's the real deal. You guys want to try this one? I'll give you a few minutes. We could talk about it in class.